Welcome back to Chapter 2, Testing Throughout the Software Development Lifecycle. We are at Part 2.2, Test Levels. A group of test activities that are organized and managed together. A quality test level should include specific test objective, test basis, which is where work products that make the test cases, a test object, which is what is being tested, 2 typical defects and failures often found at this test level, and 3 specific approaches and responsibilities for this test level. Test environment. Each test needs a test environment. Should always have a production level environment. The production level environment is really what the customer would use, or what at a store maybe like a clerk would use, depending on what the software is. So at my work, we also have these 4 steps. They have different names. Instead of unit testing, we call it user. I don't know why. Instead of integration testing, we call it RC, which is for regression and confirmation. Instead of calling it system testing, for number 3, we call it staging testing. And for number 4, acceptance testing, we call it production. So those are the 4 that we go through. And basically, level 1 is where everything is created. Level 2, 3, 4 is basically where you filter more and more to find any errors in the system. Component testing is unit testing or mobile testing. Like I said, at my work, we call it user testing. This is basically if you just took the project and you broke every single little thing down into pieces. Each piece would be a component, and you were testing each of these components. So if I were to take the component of a vehicle insurance plan, and it passes, and then I take a watercraft insurance plan, and it passes, and I take a home insurance plan, and it passes, I say, okay, all 3 of these components are good. Let's see what we can do to rearrange things. Vehicle and watercraft together, their insurance plan passes. Vehicle and home insurance plan passes. Vehicle and watercraft and home, I put these 3 together. These 3 components create a failure. What is the problem? So different test levels have different objectives, and the objectives for component testing should include reduction of risk, prioritizing the high-risk issues, basically anything that you have that is more important, especially if you're doing something like medical or anything that involves privacy. Those are the issues you should always look at first. Verification that component is working as it should, creation of confidence and quality of components, detection of defects in components, and prevention of defects from escaping into later tests. You always want to make sure that once you find the bug, you fix the bug before it leaks into the next step. Component testing, test basis, concentrates on what each component is supposed to do, and the work products for the test basis should include a detailed design, the code, data model, and component specifications. The test objects concentrate on what is actually being tested. The test objects for component testing should include components, units, or modules, data and code structures, classes, and database models. Component testing, typical defects and failures. Defects and failures found in the component testing, often incorrect functionality, like the component does not work as specified. Let's say that you are trying to log into Facebook, but every time you type in your password correctly, it doesn't work. Then it is not working as specified. It's an incorrect functionality. Data flow problem. System forgets data from one section to the next. If you were filling out an application for an insurance company and you were insuring your home, you put in your address, and when you get to the next section where it says what is the address we are insuring, and you expect it to flow from one to the next, or even in the billing section, and it doesn't show up, that is an error. Incorrect code or logic. You click on one item and another one shows up. Let's say that you are on a website shopping for clothing and you click on a t-shirt, but instead they show you pants. Something's wrong. How do you get to the shirt? Component testing, specific approaches and responses. Usually the developer who wrote the code will also test it or have a colleague test it. This is pretty much normal, and it's exactly what you would expect. Of course, when you do your work, you check to make sure it's correct. That's still not the same as sending it to an actual tester. At this point, bugs and their fixes are not formally recorded, but they could be if you wanted to do a root cause analysis, depending on the management's style and preference. Usually it's just not necessary at this point. TDD is test-driven development. Test-first approach that is highly iterative and adds small bits of code with tests until it works, and then more is added. Integration testing. Test the interactions of different system parts with each other. Includes testing operating files, file system, hardware, etc. Based on software, system design, system architecture, and workflow. Objectives of integration testing should include reduction of risk. This is the same as before. Verification that components are working together as they should. Creation of confidence in quality of interface. Detection of defects in integration. And prevention of defects from escaping into later tests. Integration testing, test basis. The work products for the test basis should include software and system design, sequence diagrams, interface and protocol specifications, use cases, architecture at component and system level, workflows, and external interface definitions. Test objects concentrates on the interaction. Test objects for component testing should include subsystems, database, infrastructure, interfaces, APIs, at program interfaces. Integration testing, I have a really good example of this, and it's not software related. When I was in graduate school, we had to read a Harvard Review article about a school rowing team. And in the rowing team, there was the varsity and the junior. The varsity team had all of the students who had the fastest rowing time. They ran the fastest. They could jump the highest. And they could do everything the best. And the junior team had all of the students that they couldn't jump very high. They couldn't run very fast. They couldn't row very fast. None of their individual scores were really very stellar at all. But for some reason, the varsity team, who had the better athletes, always did worse than the junior team. And they could not figure out why. And they match and mixed different players on each team and the coaches and the environments and the dates and times. And it was really a very interesting study because no one could figure out why the better athletes could not work together better than the less accomplished athletes. And what it came down to in the end is that the teammates on the junior team, despite all being lesser athletes, they liked each other. And because they liked each other, they very easily understood what was going on in the motions and the minds of their colleagues, and so they could work faster to always win. So it was very interesting for people to realize it's not the components at this point, it is the team. So this is a really good example of, this is when integration is most important, because these two teams were the perfect example of this. If you like your colleagues, you're going to work better. So this was always just a really interesting thing to me, so to see how these things all come together. Integration testing, the typical defects and failures found in integration testing are incorrect data, missing data, bad code, bad sequencing, or time of calls. Usually the time of calls is meant to, if one system calls into another for like a vendor information of sorts, especially with like credit cards, stuff like that. Interface mismatch, which is when the data sent does not match the data received. Failure of components to communicate, unhandled or improperly handled communication between components, and incorrect assumptions about meanings, units, boundaries of data. Integration testing, specific approaches and responses. Bigger projects are harder to find root of errors. It's always important. This is a lot of the time why they want you to document and quantify your errors within the system, because whether it's an email or a ticket or a bug or SharePoint, this helps to quantify things, and it helps to narrow things down, especially if you can find a pattern. Big bang interaction, integrating everything together all at one time. It's time consuming. You find and fix failures. Incremental testing programs are integrated together one by one with tests after each step. And it's much easier. Top down, bottom up, and functional incremental are some options. 2.2.3 system testing tests the whole system with respect to scope. The focus is on end-to-end performance. At this level, the legal and regulatory requirements are checked to go to customer. The objectives for system testing should include a reduction of risk, verification that system works as it should, validation that system is complete and will work as it should, creation of confidence in quality of system, detection of defects in system, and prevention of defects from escaping into later tests. Work products for the test spaces should include software and system requirement specifications, risk analysis reports, use cases, epic and user stories, models of system behavior, state diagrams, system and user manuals. Test objects for system testing should include applications, hardware, software systems, operating systems, systems under test, which is SUT, and system configuration data. Typical defects and failures are incorrect calculations, incorrect or unexpected system behavior, incorrect control or data flow in the system, end-to-end task failures, failure to work at production level, or failure of system to follow user requirements. System testing, specific approaches and responses, often the final test in development done with a specialist tester for individual tests. Sometimes a third party will test. It should be thorough and end-to-end. Now I want to go back to real quick, specialist testers for individual tests and sometimes a third party. I suppose I would be a specialist tester for individual tests because what I specifically do is insurance and I do it for a specific company, so I'm a specialist at that. But when it comes to a third-party specialist with like audits, that would be like accounting software or maybe software for like landlords, software for anything that's got legal requirements behind it. That sometimes companies have to pay for it and sometimes they don't. But it's usually something that a government official will be sent to do. Acceptance testing is meant to assess if the system is ready for release. If defects are found, the risk must be tolerable, such as earlier when I mentioned the two drivers on the account. You cannot have one that's 100% driving and the other that's 0% driving, but that's not likely to happen. Focus is on validation for products to go to the customer. The legal and regulatory requirements should be confirmed to fit into the scope. If you don't fit the legal and regulatory requirements, you have to hit the brakes. It's not an option. It's not an acceptable mistake, an acceptable bug. There are 4 types. User acceptance testing, UAT, operational acceptance testing, OAT, contractual and regulatory acceptance testing, and alpha and beta testing. UAT, user acceptance testing, is done by 4 or more end users. By end users, they mean customers or stakeholders. Usually the customer will decide who does it, who's considered an end user. Focus is to see if the system fits its intended purpose, done in real or a virtually real environment, meant to build confidence in the system with the users. OAT, operational acceptance testing. Focus is on operation and testing is done by the system administration. It's meant to build confidence in the system with the administration, and it's done in a simulated production environment. It's done by the administration at this point because they're actually deciding whether or not they're going to put it out. It's not often sold to a customer in this type of testing. It's like, we're using this software as our product to sell our product. So here it goes. Contractual and regulatory acceptance testing. Contractual is if the system has been developed for another company. This test is to verify that the scope and the system match, meaning, is this exactly what you had asked for? Focus on whether or not the system meets the criteria and is often tested by user or independent testers. A regulatory is focused on testing to see if its system fits legal, governmental, and safety regulations. This is tested by independent testers and sometimes requires a representative of a regulatory body to audit the test. Alpha and beta testing. Usually used for COTS software, which is the prepackaged software. Feedback is needed from user in the market before it is put out to sale for the general public. Focus is on the feedback and defects from real users. In alpha, the company that developed the software does the testing and potential users are asked to test the system. In beta, testing is done in the user's office or homes, and the users send records of defects to the development organization. It's often that companies will allow you to use their software for free in exchange that you let them track their errors. Acceptance testing objective. Objectives for acceptance testing should include creation of confidence in quality of entire system, validation that system is complete and is now working as expected, and verification that behaviors of system work as specified in scope. Acceptance testing test basis. Work products for the test basis should include business processes, user business requirements, regulations, legal contracts, standards, use cases, system requirements, system or user documents, installation procedures, or risk analysis reports. Acceptance testing objects. Test objects for acceptance testing should include SUT, system under test, system configuration and configuration data, business processes for a fully integrated system, recovery systems, operational system processes, forms, reports, existing and converted production data. Acceptance testing, typical defects and failures. Defects and failures found in acceptance testing are usually system workflows do not meet the requirements, business requirements do not work properly, system does not meet contract or regulatory requirements, or non-functional failures such as security, slowness, things that often cannot be foreseen. Acceptance testing, specific approaches and responses. Execution of test requires a test environment. Focus is to build confidence in the system or to find defects. Responsibility is on the customer or the user. Basically, you're paying for this at this point, and if you're not satisfied with it, you need to let them know. Can the system be released? What are the risks?